Okay, this problem is right max, one of the more challenging ones, and let's take a look first at what's happened with this array. We've got our input of 1, 3, 5, 7, 4, 2, and basically we have been asked to change each element at position I to be the maximum of numbers from index I to the end of the array. So you'll notice here that the element in the final position hasn't changed, and this element hasn't changed either. That's because every subsequent element to 4, and actually to 7, every subsequent element is lower. So in essence, at this point, this element is the maximum of all elements from it to the end of the array. Okay, a little bit complicated, but let's see how we're going to code this. First of all, there's a little bit of pre-written stuff here. Largely, it's to save a lot of time. Basically, I don't want to write out the user prompts every time. It's not a good use of teaching time or explaining time. So what I've done is created an array on the heap using a pointer, and then prompted the user to enter the number of values they want in the array, as well as the elements, the values we're going to enter into that array. At that point, we call the function rightMax, and the key point here is this is a recursive function. So what we're aiming to do is solve this this challenge recursively, and I'm going to use these as our inputs. So first of all, we need a base case with any recursive function. That's really essential, and you'll notice in the signature provided we were given this start position equals 0 and a length and the array. And actually, in this case, our base case is when our start position has incremented to be length minus 1. If our start position, this variable, increments to the point of it being equal to length minus 1, or let's say that's index 5 in an array of length 6, that's when we return, we quit, we basically say adios, and hopefully every other element in the array has been changed by that point. So when we're calling the function, we're going to be calling it with the array and a length, which, if we use this example, our length is 6. So each time we're going to increment our starting position, and then if that starting position is equal to length minus 1, that's when we return. But if not, we're going to be calling rightMax recursively and increment start position each time. Then, to make sure that we've got a maximum value from position I to the end of the array, we're going to need to do something with the element. Now, as I mentioned, we've gone from length 6, so start position equals 0, start position equals 1, 2, 3, 4, and then finally, when start position equals 5, that's when we return. And when we're returning, what we're going to end up doing is we're going to be in a position where we're going to go back to our call where length equals 6, start position equals 4, and we're going to need to make sure that whatever this element is, this one, it is the maximum value from this position to the end of the array, which is the neighboring element, of course. To do that, we take the myArray start position and we make it the max of the index we are at, which is in this case index 4, and the neighboring index on the right, which is index 5 or start position plus 1. But this is something that because we're calling this function recursively, we're going to be basically doing this every single time when we do the return. So starting from the right hand side of the array, we're going to start with this value and this value, and there'll be no change because 4 is the maximum of 2 and 4. And then when we reach 7, again no change because 7 is the maximum of 4 and 7. When we reach index 2 and this value, that's when we're going to get our first change, because 7 is the maximum of 5 and 7. So in index 2 it gets changed, like so. Just like that. Then we're going to go back to index 1, and between 3 and 7, well, the maximum is 7. No prizes for guessing what happens here at index 0. Basically, between 1 and 7, our index value is going to change to the maximum, which is 7. So, just to make sure that this code is working and complete, how many values? Well, 6 values, please. Okay, 1, 3, 5, 7, 4, 2. And printing out the completed array, you can see that each element at position I is the maximum of all entered values from that index I to the end of the array. I hope that helps.